Hello everyone. The following is a conversation on the research and career options in the field of computational physics in Europe. The guest for today's conversation is my good friend Madhav Sharma, a PhD student in the University of Grenoble in France. Graduating from IISER Bhopal, he has a distinguished record of research in the field of quantum computing, with academic scholarships, contributions to IISERs all across India, and collaborations with major industry players like Capgemini. So his profile leaves no ticks unchecked. So without further ado, very happy to have you here, Madhav. Welcome to the channel.
Thank you, same here. It's a pleasure to be with you.
So Madhav, today we'll be talking about a lot of interesting topics. We'll also try to give our viewers some idea on how this career looks like and maybe answer some common questions. Some of the questions that an ordinary person might have, right? Like why study this field? Who should study this computational physics? What kind of impact this field is having? Where is the right place to be? So these are some of the common questions that people will be having, right? So we'll have a brief chat on that.
Sure. Yeah.
To start off, right, could you, I think a right place to start would be to get a brief idea of where you are coming from. So, what kind of background you have, how you got into computational physics, so how you started in IISER and ended up in Grenoble in France, right? So, could you just briefly walk us through what your journey has been?
Yeah, sure. So, like most of the Indian students, like I also dreamed to get into IIT. Like after 12th, we all went to the coaching. I assume that most 90% of the Indian students have went to coaching, either to go into medical field or engineering. So my option was similar, either medical or engineering. I choose engineering, but when I was in 12th, I also attended some science camps and things. So I started looking out of engineering, right? Like everyone is doing engineering, all every people is doing it's like going in a herd, right? So I thought let's think different, and so I decided to go into IISER, and it's like IITs for science kind of thing. So it's like and it's pretty new, so it has not been so much popular. But since I come from I grew so I completed my 12 from KV Kalpakam, so I was surrounded by scientific minded people. So our community knew about IISERs, so it was quite popular in my school. It's not so quite popular in other like normal urban areas, but still. So I decided to enroll into BSMS physics. In IISER Bhopal, in first 2 years, we are taught all the courses, all the subjects, irrespective of your major. And then in the third year, you select a major, so and you select a minor. So I selected physics as my major subject, and then I was also interested in engineering, so I had a minor in electrical engineering and computer science. So I didn't. So at not any at in any point I have not left engineering. I just hold hands with engineering, but also try to come out of it, like look into other things. So yeah, so that has been my journey, and then I got a scholarship also to continue my studies in IISER Bhopal. It's called Inspire Scholarship. Yeah. So yeah, so things just got into hands, so I just went into physics. Yeah.
Superb, superb. So, could you just walk us through the point in which you decided your major and the minor, right? So the first 2 years it will be common for all the people. So, but the second year it seems like you're making a crucial decision by choosing your major and the minor. And I'm also interested in which after the second year point, how did your career diverge and it ended up you pursuing a PhD in computational physics.
So one of the major problems I have identified in Indian education system is like early on in 12th itself, students are forced to select a major, right? You either go to a mechanical engineering, like at the time of counseling itself, you either select a mechanical engineering, or you select computer science, or you select electronics engineering, or you select physics. But IISER and I think now IITs also, but IISER were different. So they didn't force you to select at the time of counseling. You get to you for the 2 years you just explore all the subjects. You get your basic strong, and you get your hands dirty in all the subjects. So they were experimental physics kind of thing, and it had so many other sub branches like condensed matter physics, the Hertz spectroscopy, ultra fast spectroscopy, Raman spectroscopy. There were so many spectroscopies in experimental physics itself. That's the small part of it. There are other options, and then there comes theoretical physics, where you learn about string theory, and you just you do cosmology. I mean, you learn about the space, everything. Big Bang theory is part of it. and everything else. Basically, you answer the question like how the universe came to be as it is now, right? Like most of the questions asked by Stephen Hawking kind of physicist. And then there is other field called statistical physics, quantum, which is very old. Like from the Boltzmann is one of the famous statistical physicists, and which has contributed to other fields, and which has like much connection with the today's data science engineering or machine learning fields, right? It has evolved from the statistical physics, the core concepts of statistical physics, right? So in my third year, I did an internship with in my IISER itself. It was like 1 month internship in soft matter physics. It's nothing but you learn about you try to model simple physical phenomena that you see in nature. Like if you put balls of different size in a box, how they arrange themselves. You just give a shaking it at some frequency, how they arrange about, and how you can simulate this on a computer. So basically, if you want to simulate this on a computer, you need to write elaborated mathematics, like what's happening, how these balls are interacting with each other, what's the packing ratio, kind of thing. You have to calculate everything and then put it on a computer, and you have to simulate. And this will be validify your theory that you come about, your mathematics you did to explain this, right? That's soft math physics in small sense. And I did a very small internship on that, which made me think, okay, I am interested in coding, I'm interested in maths, but I'm not interested in validating it by experiment, right? I have to set up the experiment, right? You have to create a box, you have to search for different types of balls of same density, of same material, and then you have to put it, and then you have to try to shake that platform in certain. So you have to do everything from scratch, right? So I was not interested on the hard labor part of thing. I was interested in coding and behind the maths of it. And then in the third year also, okay, from third and fourth year, like third year was lost for me into COVID. I believe like most of my batchmates or my generation people have lost their 2 years due to COVID, and they had to sit in home, and then they had to figure out ways to work from home, right? Kind of thing, right? So then all the experimental physicists and every physicist were forced to work on a laptop, and like everyone was forced to do computational physics basically, right? And so that time, like, yeah, I was the person who like very much enjoyed that, doing coding and doing that. And I think that was the turning point in me, like, okay, I will do it further, I will go into it into deeper.
So I'm also curious, like, how are the other people in your batch, right? So IISER, it may have like some 60, 80 people, I assume. So how many people are there in IISER per batch?
So ISO intakes at my time it took 200 students, and but all the 200 students does not go into physics, right? Only like so in the second year, let's say only 50 to 40 students select physics, right? So the my batchmate who were studying in physics, there were only 50 students. Apart from me, they were
Okay.
studying
So out of the 50, okay, so now you are one example who went into computational physics. So what are the domains are some of your other like friends and peers? What are the other domains that they're looking?
yeah. So it's interesting. So some of my friends has went into theoretical physics. They have enrolled a PhD in US, most in the prestigious US universities like Princeton University kind of thing, Harvard. Yeah, one of my junior has went to Harvard, not anyone from my batchmate. Yeah, but one of my other friend batchmate who worked in CERN, who did his master thesis. So we are expected to a 1 year proper 1 year project, and we call it master thesis, and it should be like dedicated project. So one of my friends did it in CERN, Switzerland, and now he's in Oxford. So he does in high energy physics. And this is like I'm saying, just my colleagues who have went into research and academia. There are other sets of my colleagues, my batchmates who have went to do MBA from IIMs, or of other institutes, and they had taken a corporate job after
So
they.
how about in the field of like science, what are the other domains? Like one is computational physics, I understood that. So your friends who went to Oxford, Princeton, so what are the domain that they are working on?
There is astrophysics, where you learn about what to say. You get data from radio astronomy. So there are many telescopes in Pune and other parts of the world. In India, there is in Pune, and then there is in in Nainital there is a very good telescope, and then there is radio astronomy. So basically, you get radio signals from them, and you detect exoplanets. That's astrophysics, and then there is like condensed matter physics. That's where I come in. So and then so you learn you cool down your material to like sub Kelvin levels, and then you study how they behave. So there is an experimental part to it, and there is a theoretical part to it. So these are like very broad five topics I can just think about now, but there are many. So these are like five major, and then these are like subdivided into more than 10 subfields, right? Okay. So don't guess that these are only the five particular parts in physics. These are like very much subdivided, and yeah, so many options.
You mentioned a lot of interesting names. Like you mentioned like Princeton in the US, which is in a different continent. You mentioned like CERN, which is in Europe. Then you mentioned like Oxford. All these different places. You are from India as well. So I'm just curious on like where the innovation is happening. Where is the right place to be, right? I'm also interested on like why you chose France as a place to do your PhD. You might have other options. So could you just like walk us through like when you applied for PhD, what places did you apply to? Why did you decide France was a good place? Where is the best place to be? So could you just like shed some insights on that?
Yeah, so basically, if I would say, if so, I will talk about only my field because I don't want to comment on other subfields since I have very less knowledge about it, right? So I am doing my studies in computational physics, and then before that I have worked in quantum computation. That's a subfield of computational physics. So if you're working in quantum computation and kind of that field, US is the best option to be. Okay, that's the place you have to be if you are very serious about quantum computation and like you want to do research in that and from an engineering perspective kind of thing, right? So there are so many startups, and then there are big names like IBM, Google, who are working on quantum computation and who have developed they're developing their own quantum computers. And then there are academic research institutes like University of Arizona, and then there's like University of Massachusetts, and there's MIT, Massachusetts Institute of Technology, and then there are other like major research institutes, Stanford, Princeton. Everyone is doing research on quantum computation, and they are doing cutting edge research on that. There's no doubt on it. But why I choose France and did not go to US, even though my field was there and it was booming there, is like very different reason. It's nothing to do with academics. I just needed a work-life balance in my life, so I choose not to go into US academia because it's like people are stressed out there. Like you are expected to publish in 1 year. In 1 year, you are expected to publish at least one paper, right? One research paper, and I don't feel if good research happens in that kind of stressful environment. And there is some culture like publish or perish kind of thing going on in US. So I'm not fond of US academia. It's like very stressful, and they do meaningful research, but that's like they publish 100 papers, and out of that like 10 papers would be very much impactful research, and the 90 papers would be like just for the sake of publishing the research and
Got it. So could you, when you come to Europe, right? Because you are at Europe, what are like the hotspots where research on computational physics is happening? Okay, and where did you apply to? Among the hotspots, you might have applied to like certain places, and like why specifically Grenoble, right? Like why were you attracted to their specific institute? So could you just like walk us through that?
Yeah, so as I was saying, I had applied to some German university, but as such, I have not applied to French universities while applying to Europe. But I had applied to some French labs, CNRS labs, where research happens. But I didn't apply to any French university labs. I didn't know at that time because I was just applying to so many. So and then I came across some fellowships also in Europe. So I was also applying to fellowships. So there is like Marie Curie Fellowship. It's like called Marie Curie Co-Fund and Marie Curie. So Marie Curie Fellowship has been subdivided into different. So for each field there is a Marie Curie Fellowship. So and mine is again a special fellowship that was to develop quantum related technologies and related things in Grenoble area. Okay, in French area of Grenoble. So and so Marie Curie Fellowship was given for that students to carry out research in quantum technologies in Grenoble in research labs in Grenoble. So you can consider Grenoble like the French city of Grenoble as like Indian city of Bangalore. Here most of the tech companies are here in Grenoble. So and then there are many and then University of Grenoble is a quite old university. So there is a community of students, there is a community of tech people. So here all the research happens, cutting edge research happens on, let's say, tech, right, for France, right? And
You mentioned about the people, right? Nowadays it seems like you're going abroad and you see more Indian and Chinese students than the actual natives. So, how is it in your place? So,
they are Asians, okay, so they are like people from Vietnam, and then people from from India, so mostly from Indians and Vietnamese, and then French people itself, and then from their people from Italy and Russia, who they research in France. These are the most people I have seen in France, apart from French.
Many number of openings are there. So through the Marie Curie scholarship, like you got into this university and this position. Generally speaking, right? How many positions are there in most of these universities?
Yeah, so the position is like unlike so in India it's like if you apply to a university, like they take 5 students to a PhD admission, and then after second year they decide on what topic to do research inside physics itself. Right? But in Europe it's not like that. So I can't comment of the positions because like positions are itself very well defined in Europe, right? It's like so the time of you applying they will say you are going to do research on this topic. You're expected to do these things. You're expected to produce these results in or I mean, these are the goals. These are the things you have to achieve in the next 3 years. These are the things you have to cover, kind of thing. So it's well established position, right? And so the position itself is like well defined. So not many people can apply to that position. Only people who have specific skills will be concerned. If a student from who does not have any skill applies to that position, he will be rejected. As usual, his CV will be they won't even read that CV. So like the positions itself are well defined, right? So you have to be patient, and you have to keep looking to all the positions, and you have to see which one matches your needs, and which aligns with your career perspectives and your research interests, and then you apply to it. And if your CV is like very much let's say very much overlapping with what they require, then 90% of time you will be called for an interview, and then rest depends on how you perform in your interview, and most of the times people convert it, right?
Under the Marie Curie scholarships, are there like any other universities which are coming under it?
Marie Curie is like a fellowship given by the European Union, so it does not depend on any university, right? So they are like Marie Curie Fellowship like very independent, right? And so the proposals are so either the student can connect to any researcher who is working in Europe under any European university, and he can connect to that researcher, and they both can write a proposal and submit it to the European Union's Commission for Marie Curie. And then Marie Curie, there will be an independent committee of Marie Curie who will evaluate that proposal, and then they will decide if they have to release that grant for this project, and then the student will get a PhD stipend out of that grant, kind of thing. Or else then there are some research project under Marie Curie website. So there is a website for Marie Curie where there are many research projects listed, and those will be funded by the European Union Marie Curie Fellowship, right? And then you can apply to those projects, and then in that project the supervisor's name will be already written there, right? And then you can contact with that guy, and once he is okay with you, then the Marie Curie committee will call you for an interview, and then you give you an interview, and then they are also happy, then you are get selected. So there are no universities that come and as far as my knowledge goes, there are no universities. So all the European unions, all the university that comes in Europe are eligible to apply to Marie Curie Fellowship, right? It depends on the student if he receives it or not. My MS thesis, I collaborated with Capgemini, and they were like very good. And so even after my MS thesis, so it's a 1-year project that you have to do in your final year of your BSMS. Even after that, they were gracious enough to give me a 6 months extension. So they offered me a 6 months internship with them, so that I can continue on that project. And then I continued on that project, and after that, at that time I also got PhD in Grenoble, so I moved to here, and still I am in contact with Capgemini, and I believe next year I will do again a 2-month internship with Capgemini. So one of the criteria for Marie Curie Fellowship is that you have to do a 2-month internship with a doing your PhD, when you offer the Marie Curie Fellowship, you're expected to do a 2-month internship with an industry partner, right? That's one of the criteria of Marie Curie. So I would say if you want to do a research, if you want to do your PhD in Europe other than Germany, then I would consider apply for Marie Curie Fellowship because it's too good. It's good because you will have an industry exposure also, right? So if after PhD, if you don't want to go into academia, let's say you don't want to go into postdoctoral research and you don't want to become a professor, then after PhD you can just discontinue your academia and then you can switch to industry right away because you have contacts with industry partners, right? Yeah, that's an advantage in Marie Curie. So in IISER Bhopal, we are expected to do a 1-year project, proper 1-year dedicated project as your part of your final BSMS, final year of BSMS. And that I did. That interestingly, I didn't do it from the physics department. I interestingly did it from engineering department. I collaborated with a professor in the engineering department, Dr. Ankur Raina, and he had attended a seminar in University of Science given by Capgemini people, guys from Capgemini Quantum Lab, and he was pretty much impressed with their presentation and the thing they were trying to do in Capgemini Quantum Lab, and he believed that our project is in good align with their research interests too, right? And so he contacted the Capgemini guys, and then they were interested, and we had an for 1 month so then he put me in touch with them, and then we had a discussion on our project, and then I explained to them what I was trying to do with my project. So my project was on application of quantum computing in finance, and they were also very interested, and they agreed to contribute to it and help in any ways we need help, right? So basically at that point we didn't have access to IBM quantum computers, so we had some unproven algorithms or unproven methods we had in our hand, which we needed to implement on IBM quantum computers and get a proof of concept kind of thing, right? And so for that, Capgemini helped us to put it on quantum computers because they had a connection with IBM people, right? So this is how you build your network, right? So you catch one professor who is interested in your project. He builds in rapport with industry guys. Industry guys build rapport with another industry partners. That's how things work. So I think networking is very important. And so then after that, so 1 year project I did with them, and after 1 year project, the project has been not as such from an academic perspective. I had met all the requirements, but the project has not, from our perspective, from our satisfaction, it has not ended. There is much more that I can do on the project. So then Capgemini guys offered me a 6-month internship with their group, with their company, so that I can continue on the project, and they can also and I can bring it to a finish, right? And so that was interesting, and then I continued, and during that period I applied for PhD in Grenoble. I came across a PhD position in Grenoble, and I applied for it, and it comes in Marie Curie, and one of the requirement for Marie Curie is that you should have an industry partner, and you should do a 2-month internship with that industry partner. At that time I was exploring I was applying to different and the cost of internship will be covered by Marie Curie fellowship, right? So the industry has no does not bear any cost, right? It's like they get free of kind of labor, right? And so it's basically to help the student to get an industry exposure, and they will cover, the Marie Curie Fellowship will, or the grant will cover all the expenses of that project, anything that the student needs to do internship in industry, right? So at that time I again applied to different European companies that were located in European region, but I could not get my application was nowhere successful. So then I again contacted Capgemini guys, and then they were again helpful, and then they said that they were ready to give me another 2-month internship as part of your PhD whenever I needed, right? So most probably next year I would again join Capgemini for a 2-month internship as part of my PhD research. And that's how my industry relation with Capgemini is at this point, and it's going. So yeah, so always have an industry partner with you, and be relevant, if even if you're doing research in academia, see what the market is like, what trend is in the industry trend, right? Be aware of what is going on in the industry. So even if you want to switch out of academia at some point, many researchers from my field have just switched out of academia. They have joined Google R&D, IBM R&D, because now quantum computing is really picking up pace, and industry guys like Google and IBM need people who know quantum computer, and there are no people because there is no course in quantum computing as such, right? There is MSc in artificial intelligence, MSc in data science, but there is no MSc in quantum computation. There are only 2 to 3 institutes in India that offer MSc. So IISER has just recently started an MTech in quantum computing, but that's pretty much new, right? So there are very less workforce who knows quantum computing and who can do coding from a quantum computing perspective, right? So there is really a gap in the market, right? And they need coders who know quantum computing and who are good in this kind of thing. And so yeah, so what I want to say is that like, even if you are in academia, see what the market trend is, and always have a skill, keep upskilling yourself, and based on the industry requirement also, so that at some point, if you get just fed up with the academia, you can just have options up and you can just switch your career, right?
Got it. So you mentioned like two interesting things. So one is related to like the industry connect and how the networking aspects work. Okay, so I'm just curious on how it helps you like land a job, right? How does one land a job in this field? So that's one question that I had. And another one, you talked about like the coding related to like quantum computing, right? So could you just explain how that works? Because I'm a coder as well, and I'm just like I'm interested in knowing like what kind of programming language is there, or what are the technologies that are behind this. So could you just address these 2 points?
First point, like how you land up in a job. So interestingly, while I was doing my 6-month internship with my Capgemini guys with Capgemini, they had offered me a job. They had offered me a full-time role in Bangalore, and they said that they wanted a guy in Bangalore who can like anchor and who can deal with the clients. So there were some major automobile clients there. So they wanted someone to deal with them and guide them on how to use quantum computing in their field, right? So yeah, so they had offered me a job, but I declined because at that point I wanted to upskill myself because I was not ready. I believed I was not ready to take up a full-time job in quantum computation. I needed to learn more and explore hone my skills more. So I preferred to do a PhD. But then yeah, so that's how. So yeah, you just keep you just keep networking with the industry people, and they have contacts, and you need to know what the industry needs, right? What skills are they looking after, right? As such, today if you know coding, that's not a big deal. I mean, everyone in India, more than 90% of people, I think, who are students knows coding, right? So if you were a person who were in the 1980s kind of thing, and you know coding, that was something new at that time, right? And people didn't know, so that was a skill that was in demand at that time. But now no more coding is in demand, right? But at the same time, if you know if you have worked on machine learning projects, even if it is not an industry project, even let's say you have just done a research project on machine learning, let's say in astrophysics. One of my friend uses machine learning algorithm to identify stars and galaxies to classify them, right? And he uses machine learning classification algorithm, right? And he has published his results on journals. So next time when he applies to an industry, he can say that he has worked on, even though if it is not an industry project, he has experience with classification algorithms, and only thing he needs to do is like, instead of classifying galaxy, he just needs to classify dogs and cat, and then that's like what industry needs, right? That was like 5 years back, I'm saying, right? Now everyone knows classification algorithm. Now that's also not new. Now the new thing is like quantum computation, large language modeling, this kind of thing, how to use ChatGPT kind of thing, right? So you have to always see what the industry needs, right? And you have to keep on skilling up yourself, and then the opportunities will follow. Because if there is a gap, and if you can fill that gap, then why not? Industries will like hire you, right? And for the second, what was your second question again? Coding, right? Okay. Yeah. So yeah, what's quantum computing, and what's coding languages used in it? Okay. Yeah. So basically, so we use Python only, but there are packages, right? If you can just do a Google search on which is called IBM Qiskit packages, or Penilyn quantum packages. So there are packages on based on which you write your algorithm on you use functions on of those packages, and you develop algorithms based on that. And so any code written using those packages can be done on a quantum computer, and then that's the coding part of it. But then you need also knowledge of quantum algorithms, right? Different algorithms, and then you write on that, right? So that's the theory part of it. You can just do a quick Google search, quantum algorithm, top 10 quantum algorithms, and then Grover search algorithm, Shor's algorithm. These are some famous algorithms of quantum computer that just pops up, and then you can read about it, and then you can code those algorithms using IBM's Qiskit or Penelline's quantum package. Or even Microsoft has a package called Cirq, I think, SCIRQ. So that's again a quantum package. And then even Amazon has Azure. So Amazon Web Services has Azure. So they also give many backends to quantum computers, and you can that Bracket. So it's called Bracket. That's the package developed by Amazon Web Services for writing for coding in quantum. So yeah, these are the different coding packages that you can use, and then you can just translate these Grover algorithms or Shor algorithms using these packages. You can write it at, and then then you're good to go. So you have basic knowledge. If you do this exercise, you have basic knowledge of how quantum computers work and how to code in quantum computation, and then that's a skill, right? Again, and you can work on it. Yeah.
Very interesting to see you talk about how the field has like grown over the last 5 years, right? The classification of like cats and dogs that are like okay in 2017 but not in 2024, right? So things are like moving fast in the IT industry. Things are moving fast, and you seem to be like suggesting that quantum computing may also be like interjecting with IT in some way. So myself working in this industry, I'm like very curious on like how things are going to go forward on how quantum computing and the fields in IT like machine learning or cyber security, how these are going to pan out. So do you have any views?
Yeah, so cybersecurity is going to be disrupted soon due to quantum computers. There's called quantum cryptography kind of thing, and all your cryptographic, so you have to change. So even today, 1 week back, there was National Standards of America that has released that they should migrate all their servers to quantum safe cryptography protocols. So cybersecurity is a field that is going to be very soon disrupted by quantum computers, and you need people who have knowledge in quantum, who can code in quantum languages, so that they can just shift the servers to this new protocol. And then there is finance, which is also again going to be disrupted. So I think since you come from a fintech background, I believe you would have worked on fraud detection kind of thing, right? So credit fraud detection kind of thing. Yeah. So
Yes.
those are where machine learning algorithms are used. But then again, machine learning algorithms are very hard to train, and the accuracy is like it's like comment. I won't say so good. So there are some quantum algorithms that can help improve your accuracy. So you say there's something called as quantum machine learning algorithms, right? So there are some machine learning models that can be run specifically on quantum computers, and they can be trained on very less data, and they can give accuracy, very good accuracy, right? Prediction accuracy can be very good, right? So that's a point where people are trying to use quantum computers for credit fraud detection kind of thing. And then there are many if you want to look into this more, there's a startup called Multiverse Quantum Computing, who are very much working on like finance and fintech background of like how to use quantum computing in fintech, right? For this credit detection kind of thing, right? And they have done a tremendous job in that. And then they have also done a very good job in compressing large language models, right? So LLMs are the new keyword in the industry, right? But these LLMs are very hard to train, and they just so there's an interesting fact that I would like to share, like so the amount of energy is used by these servers in NVIDIA or kind of OpenAI. So they consume about 3 times more energy consumed by Germany in terms of energy, in terms of electricity. So you can see like how much energy is being these servers are just pulling out of the electricity grid to just train their models, right? And since ChatGPT has become famous, every industry or every industry player wants their own LLMs, right? So just imagine how much electricity will just be used to train this model, and how much electricity bill
Okay.
this industry
Okay.
has
So you are mentioning, right, there are things that the industry needs, and we as like researchers, you need to like be able to identify the things that the industry really wants. So what is your opinion on this quantum machine learning? Do you see this going anywhere? So why quantum machine learning, by the way? So that is also something, right? Like whether it's the computational power, or is it just like a different mechanism to improve accuracy? So why quantum machine learning, and is this like going forward in the industry anytime soon?
that the energy requirement for to train these LLMs is very huge, right? So if I say that if there is a research that backs that saying that quantum computers require only 1/10 energy, the energy requirements are only just 1/10 to run a quantum computer, and they can train them. They can and they are very so energy wise. These quantum chips are very efficient. If I say that, and then even computational wise, like they are more accurate. If I say that, these are the two things that are already advantages for the industry to just switch to quantum computers rather than to classical computers for computation, not for all purposes. So we say quantum computing. There is a new term in industry called quantum processing units (QPUs). So it's like GPUs, right? So there are some tasks that our QPUs are very good at doing, right? And there are some tasks that GPUs are very good at doing, and then again there are some tasks that CPUs are very good. So we need to identify which task is very good for the QPUs, and if you just like parallelize those tasks, or you just divert those tasks to QPUs, and then you can save a lot of energy. So it's true, like quantum. I'm just not faking it. So it's really true that quantum processing units really take up very less energy compared to for operations compared to the CPUs and GPUs you have. But then there are some tasks that QPUs can't do. You need the CPUs to do. Yeah, so it's like paralleling your task and identifying
So
like which task.
let's briefly talk about like what India is doing, right? So whenever you're talking about this open AI, it's in US. Like I think India is just starting to catch up in the supercomputer game. So as far as the quantum computing is concerned, like where is India currently in?
I mean, it's a tricky question because India, like what I feel is like India has already missed the train of AI, right? Like other people have just overtaken India in AI, right? We are still stuck on that IT software servicing kind of field. We are not. I don't think we have much progress because the main problem is the resource, right? If you need to train your large language model, you need access to GPUs, and that too not one or two GPUs, very a huge set of GPUs you need access to. Similarly, if you need quantum algorithms or quantum things to evolve in India, you need access to quantum computers. And currently, India does not have a quantum computer. Okay, so US has its own. US has many quantum computers. Like Google has its own quantum computer. IBM has its own quantum computer. In fact, IBM has more than one. It has like 5 to 6 quantum computers of its own, right? Just one company in US has its own 5 to 6 quantum computers, right? And India has none, right? And China also has its own quantum computers, and they are developing more powerful quantum computers of their own. So from a software perspective, okay, it does not matter. I can develop quantum algorithms. I don't need quantum computers for it. I can use cloud Amazon service, and if I develop an algorithm, I can just use Amazon Web Services to for it to implement on a quantum computer that is situated in US or in Europe, right? But that's not the case. If you want to really have if you want to really things to kickstart in India in quantum computers, and you need a quantum computer at your own disposal, right? Because
Got it. So you're talking about hardware, right? So yeah, hardware is another interesting thing. Now that you bring it up, so who are the guys who are like developing the hardware for the quantum computers?
IBM is the major player in here. So IBM is the
Okay. So what kind of background do these people have to be on the hardware side? So you're on the software side more of. So, but to be on the hardware side, what kind of background do these guys have? What kind of expertise are they bringing? Skill sets?
Since I am a theory guy, that's why. So as I said, physics is first divided into two categories. One is experimental people and one is theory people. So the experimental people who do these things go into hardware side, and the theory people who go this, who they do like a software kind of thing. But other than that, even if you're not from in physics, like there are electronic engineers who are working on control systems for these quantum computers, and then there are all the electronics engineers are also working on this hardware side, and then there are experimental physicists guy from condensed matter physics who are working on this, like how to cool the computers to sub Kelvin levels. That's the thing. And then some people, some experimental people have so some physics people, theory people have even suggested that you can change if you can use another technology to do this quantum computer. So currently the industry has not decided on like what platform to use. So they are for developing quantum hardwares, you can use superconducting qubits, you can use silicon based qubits, you can use diamond qubits, and there are many platforms, right? There are many ways to develop quantum hardwares. And so industry has not at this point industry has not agreed on one platform till now, because it's a very new field and people are like exploring kind of thing stage. And once you have expertise in experimental physics, I would say in condensed matter physics, or if you're an electrical engineer and if you have done control system kind of thing, you also have good knowledge of electrical engineering, then then also you can get into quantum hardware kind of system. So yeah, basically you need a good understanding of electronics, how it works, and physics, again physics, what kind of physics you are going to do there, kind of thing. If you have good knowledge of this, you can easily get into it.
Got it. Got it. So you had also mentioned about the finance industry, right? So could you just like give an insight on how things are getting disrupted? Because I'm also seeing like hearing about all this AI and all the algorithmic trading systems. I know the machines making like quick and capturing all the market data, making quick trades. So I'm just interested on like knowing more about like how this field of like quantum computing or new computation methods, how it's disrupting the finance industry.
Yeah, so currently it's all in papers, right? So basically we don't have a good hardware that can run the quantum algorithms at a good scale, at a good speed, and because the results are just noisy, so we don't have, so on paper we have an advantage, but we have not yet translated it on a practical use case kind of thing. But it's believed that since we have an advantage on paper, it's just matter of time that experimental physicists and electrical engineers just find a way to just develop the hardware at a more accurate hardware. So it may happen in next 5 years or in next 10 years, but I can assure you that it will happen, right? Since at that time no one knew like when the AI would come, but everyone knew that AI and LLM will come, right? So quantum computers are also in that phase. It will come, but I can't say when it will come, right? But when it comes, it will disrupt things, right? So when ChatGPT came, it disrupted the industry, and like now everyone is behind LLMs. Everyone wants to develop it. So when once the quantum algorithms, quantum hardware develop to that point, and when we are able to implement those algorithms and we are able to make meaningful predictions in market, right? Then the situation will change. Then all the players in the finance industry would want to have access to quantum computers, and would want to have access to want workforce or people who have who know who have knowledge in this field, right? Even if I say there is a dedicated JP Morgan a research group who works on quantum applications. Okay, so there is a JP Morgan R&D group that are dedicated on developing quantum softwares for finance industry. And then there are startups, and even Goldman Sachs has its own R&D. So every big financial names or people in financial players already have their own team who are working on quantum algorithms for finance, right? So they are already prepared, right? Or they are preparing themselves, because they don't, so everyone misjudged AI, but no one wants to misjudge the next tech revolution in quantum computation. So everyone is getting prepared themselves. So yeah, it will happen, but I can't say when it will happen. Everyone is just preparing to just embrace that change.
Now, right, let us give some advice to like people who are like looking to enter this field, right? So what I want you to do is we'll just like summarize whatever we talked about education, about the career, about the networking, all these things. So I want you to give like quick one sentence answers maybe, so that people when listening to the section, they can just like in a summary they can understand everything. So educational background, what is required?
Either a BSMS in physics or a BTech in electrical engineering is fine enough. You're good to go.
Where is the right place to go and study these fields?
Yeah, so interestingly, since PhDs comes with stipend, right? So there's nothing, even if you go to US or even if you go to here, you are not expected to pay anything from your pocket. Everything is covered by the government, right? And you get a monthly stipend to cover your monthly expenses, right? And so unlike a master's in US or masters in US, you are not expected to pay anything to, you are not even expected to pay the tuition fee. Even if you are expected to pay tuition fee, it's a minimal amount that can be covered from your stipend, right? So it's not, so financially it's
Okay,
not
that's
going to be,
it.
yeah. And in,
Okay.
yeah, Europe also it's not going to be any.
Okay, awesome. So next, let's talk about what the industry really wants. So just give me like a couple of like you know high level subdomains the industry actually cares about. So you were mentioning about the gap rate. So what are like the top three skills that the industry needs in this domain?
Okay, so you need to be good at coding, right? You need to be good at translating mathematical formulas into codes, right? And then you need a good understanding of quantum mechanics if you want to go into quantum computation, right? And then you need to have a good knowledge of packages that are out there. So that comes in coding itself. Like you need to be good at anyone quantum packages, right? So that you can translate your mathematical formulas or quantum mechanical knowledge into code, right? And then you need a good communication skills so that you can convey what you have done to the industry people, because understand that in industry the people does not come from a solid mathematical or quantum background, so you need to tone down your things. You need to make it so simple that even people who does not have any background on this thing, they understand what you are trying to do and they appreciate what you are trying to do. And if you're able to communicate your things much better, then yeah, you're good to go. I mean, yeah, that's
Got
one
it. Super.
important skill. I would say everyone should need that, a good communication skill. It's very important.
Okay, so last question before we wrap up, I want you to give a summary on the scholarship, especially the Marie Curie scholarship. I just want you to summarize that and maybe talk about the universities and the opportunities as far as education is concerned, right? So could you give some idea on
Yeah,
that?
so if you are a guy who want to apply for the Marie Curie Fellowship, or if there are listeners who want to apply for the Marie Curie Fellowship, there is a website for Marie Curie Fellowship. Or you can just type Marie Curie Fellowship. The full form is like Mary Scholarskaya. Okay, there is a middle name is something, even I can't pronounce it. And then there's, so I just call it Marie Curie Fellowship. You can just type it on, and you may be redirected to the website, or you can get a lot of information about it on the website, and then you can start applying to it. And universities, I would say if you are going for a PhD, universities not matter much. It's the reputation of your supervisor that matters, because as I said, if your supervisor knows people from academic domain and from industry domain, if he's an old experienced person, he would know people from industry domains who are working on this field, right? And he can put you in touch with those people. And then when you are in touch with the people, when so you, every time I consider like it's not the university or anything, it's the network that you build that matters the most, because at the end of the day the network will come to help you, right? If you are in a crisis mode, like if you want a job immediately, then it's not the university people you will go after. You will directly contact your networks, right? You will message, okay, I have these skills, I need a job, if you have any that. So networks always help, right? So it's important that you come in touch with like good people, right? So always choose your supervisors more more carefully than the universities. And then after that you can, okay, when you have two positions, two equally good positions in your hand, then you can start looking which university is better, which is like which country is more better to live, kind of other things, right? Secondary things, right? But yeah, if you're going to a PhD, the fellowship is important, and the supervisor you are going to work for going to work for next 3 or 4 or 5 years is person, because he is going to be your boss, he is going to be a colleague, he is going to be everything for the next 5 years in your professional life, right? You are going to communicate with him on a daily basis, right? And if he has good connections, he can always put you in touch with in a good circle, and then you can always find your way ahead in your career, right? Yeah, so that's the only
Got it,
advice.
Madhav. Got it. I think we've covered a lot of topics. We've like dived into a wide array of how this field can be broken up. You know, where is the right place to be, why to study this field, how the future is going to be. So I think you've given like very clear and detailed answers for each of those questions. I think anyone who's like interested in knowing more about this field, if they listen to this, they'll have something good to take home. So with that said, thank you, Madhav. So for all your insights, it has been nothing short of a great pleasure to host you.
Thank you.
So yeah, it was a great pleasure to have this interview. Yeah,
Thank you. Yeah.